Marco Codes! Today we're going to talk about SSH, nice and easy, and everything you need to know as a developer or a DevOps person in your day-to-day work life to work with it. Right, now before we play with SSH in a terminal window, let's just take 60 seconds or so to recap what SSH is and how it works. If you already know, please skip forward, otherwise enjoy my handwriting. Because what we need computer A, which usually is, let's say, your laptop, your desktop, PC, whatever. You want to connect to computer number B, which usually is some sort of server. The way you're going to do that is, well, who would have thought you're going to use SSH, the Secure Shell Protocol. Why is it called that? Because once you have that connection established, then no man in the middle can figure out what commands you're executing on the server, what you're doing there. Now, for this to work, what you need to do is, let's pick another color. You need an OpenSSH server installed on the server, which it basically is on almost every server installation out there. On the client, you also need an SSH client. There's multiple ones. We're also going to pick the OpenSSH client in this video because it's available on every platform, Windows, Linux, macOS. There's also PuTTY on Windows, multiple different ones, but in this video, we're just going to play with the OpenSSH client. And then the question is, well, once you connect to the server, how do you authenticate against the server? You could obviously use, you could username password, which is not entirely recommended unless you have a really strong password, a random generated password, not just my mother's birthday 123. The second way is using key files, and we're going to spend most of the time during this video to learn tips and tricks how to work with key files. Now, how does that work? Just as a general overview, at some point, you as the user, let me just pick another color, you have to generate a key pair. Key pair means you'll have two keys. You'll end up with two keys. You'll end up with a private key and you'll end up with a public key. So PR and a public key. The private key you'll have to keep safe. It's basically your key into the server. You need to store it onto your laptop and just make sure that no one else gets a hold of it. The public key you can put on any server you want to. And once you connect to the server, to a server where the public key and the private keys match, you just immediately get access to it. There's also a couple of other things, like you can actually use a password to make your private key even more safe. So let's call it two-factor authentication. But we're going to check all of this out now in the remainder of this video. All right, let's start with a very basic use case. Imagine you're logged into Amazon AWS and you want to create a new server / launch a new instance. And I'm going to call the server Marco Codes server. And when I scroll down, it doesn't matter if I'm using Amazon Linux, Ubuntu, Windows, whatever. At some point, Amazon prompts me for a key pair to log in for an SSH key pair. And I could choose an already existing one, or I'm just going to create a new one through the GUI. And don't worry, we're going to do the same thing on the command line in just a second. Now, I'm just going to call the key pair Marco Codes. And then Amazon asks me, what should the key pair type be? What encryption algorithm should I use? RSA or ED25519? Now, I'm going to link a couple of discussions to how both of them compare on Stack Overflow down below. In any case, you'll find that platforms like GitHub, for example, nowadays, they push you to create the ED25519 ones. They seem to be slightly more performant, but in certain cases have compatibility issues, like, for example, on Amazon, they're not supported for Windows instances. In any case, both of them will be secure, so choose either one. I'm just going to go with the ED25519 here. Amazon also asks you what should the file format be that the private key is in. Now, you have the choice between .pem and .ppk. We're going to use an OpenSSH client, like I said just a minute ago, so we're going to go with the PEM file. If you're using PuTTY, if you're on Windows, for example, and still using PuTTY, then please choose ppk. But for now, just choose PEM, and we're going to have a look at what such a file now looks like. In fact, we just downloaded one file, the Marco Codes PEM file. When you have a look at it, it says begin OpenSSH private key. It's only your private key file, and you don't even see your public key now. Amazon actually stores it for you and will automatically put it on the server you're about to create in a tiny second. Other than that, a PEM file is just a base64 encoded file. It could contain private key files, it could contain public key file certificates, stuff. In this case, it just contains your OpenSSH private key. So the only thing what we're going to do is we're going to now launch the instance and connect to it. So now we finally have a terminal window open. As I said, it doesn't matter if you're on Windows, on Mac OS, on Linux. It is this, what I'm going to show you works the same way for all the major operating systems. I'm just going to go into my downloads folder. What I'm going to do is I'm going to write SSH. Then I know by default that Amazon has an EC2 user for every server it just created. And then we're just going to put in my IP address. Now, the first time I'm trying to connect to the server, what actually happens is that the server sends me its fingerprint and I have to remember it locally. So this is what the question is about. It asks me, hey, this is my fingerprint. Am I sure I want to connect to this server? As it's the first time, yes, I want to do it. Now, the thing is, I'm permanently remembering that fingerprint. And should the fingerprint ever change, so when I'm going to connect to the server a couple of other times, and then suddenly it has a different fingerprint, I know either the server got reinstalled, like the OpenSSH server software, or the whole server, whatever, or there's a man-in-the-middle attack, which you can read about in the references, and you should actually stop connecting to the server in that case. Now, as you can see, what happened is I tried to connect to the server. I got a permission denied because, well, I need to specify a private key file to connect to that server. Otherwise, I can't just connect to the server. The way I'm doing that with SSH, let me pull this up a bit, is I'm actually going to go -I, Marco code spam, and then just EC2 user. And again, I'm just going to paste in my IP address and bam, I'm connected to the server. Now, what I can do is I can, list my directories. I can do a sudo yum update if I want to play with the packages on my server, whatever I want. Now, we just created the key pair through Amazon's proprietary GUI. Obviously, there's also a command line way that works for every hosting provider that also works together with AWS. I'm going to show you how to do that. As soon as you have the OpenSSH client installed on your machine, again, it is by default installed in every major operating system, you also have a command called SSH-Keygen, which essentially generates by default a public-private RSA key pair, if I don't put any parameters here. It is going to try and save my private key in my home folder .ssh and then ID_RSA. It's also going to put the public key there. Now, if you want to go with the ED25519 algorithm, just do a -T, right? And now you're creating the key pair with that algorithm. And by the way, one last thing, it also helps to give your key comment, like for example, your email address. So marco@jetbrains.com. So you later on know when you open up the key file, hey, with what person, with what account is that key file associated? So we're just going to go with that. As you can see, now the key file is being put into home folder.ssh, ID ED25519. That's fine. We're just going to go with that. Now we're being prompted with a passphrase. If I don't specify a passphrase now, anyone who has my key can actually use it to connect to my service. Now I want to use a secure passphrase instead. So I'm just going to go with dumdum123. Again, don't do that in real life, but I'm just going to do it here, dumdum123, so you enjoy this episode. Now let me just have a look at my .ssh directory. You can see here's my private key file. Actually, let's just print that out. Do a cat on Linux and Mac OS, right? You can see this is my private key. And then you also have the public key. Looking at that, you can see this is all there is to the public key. You see the algorithm, you see the public key, and you see the comment I just talked about. Now, what we're going to do is we're going to copy that public key to our clipboard. Then back to the Amazon GUI, we're going to have a look at here on the left side, somewhere it says, yes, key pairs. What we're going to do is you can see there's already a couple of key pairs I have here, starting with the name Marco, which is going to import another key pair. Import is a very fancy name for, we're just going to paste in the public keys content here. We're just going to call it Marco codes key pair, something like that. We're just going to import it and we're good to go. Now let's launch a new instance, Marco codes 2. We're going to scroll down. We're going to see Marco, there must be the Marco codes key pair, right? Launch the instance, take the IP address, back to our terminal window. We're going to do EC2 user at IP address, and we're going to log in. Again, we're getting fingerprinted, right? enter the passphrase for the key ID ED2519. So we're just going to remember dum-dum123, and you can see I just connected automatically to the server. The question is, why didn't we just have to specify the -i parameter? That is because by default, what the SSH client will do, it will have a look at in your SSH folder, is there a file which is called ID_ED25519 or ID RSA, for example, and use them automatically to connect to any service. So that's why we didn't have to do the -i. Only if you don't have your key file, your private key living in a .ssh folder and with a different name, then you'll need to specify it with the -i parameter. Now, one last thing what I wanted to show you is, because I've been talking about that Amazon, once you import your public key file, Amazon stores it for you and puts it onto the servers. Now, the question is, where does it put the key file? Easy. You have the EC2 user, which is automatically created. The user has an .ssh directory, and in there, there's a file which is called authorized keys. And when you cat this file, what you essentially see is, well, here is your public key that we just imported a couple of seconds earlier in the Amazon EC2 GUI. But instead, what you could also do, what works generally across the board, doesn't matter what the hosting provider is. When you have a server, you need to have a user with a .ssh folder, an authorized keys file, and in there, just put in any public keys that you want the user to have. Right, so we met the SSH and SSH-Keygen commands. There's another one, which is the SCP command. Now, what does SCP do? Essentially, what it allows you to do is to copy files or download files to and from server via SSH. Now, let's try that. Again, in my downloads directory, I have my Marco Codes private key. I also have a sample3.txt file. What I can do is I can say that I want to copy the sample3.txt file onto my server, so EC2 user. Hopefully, I have my IP address in here. Yes, I still have it. And then I can specify the path. For that, you need to do a colon and then whatever path you want to copy the file to. So for example, directory like /temp, or in the temp directory as I'm just going to call it sample4.txt, whatever. So you can also rename it. And by the way, if you're on Linux or macOS and you do a tab here, what you'll find is that the path auto-completes on your server, right? On Windows, that doesn't quite work. But what I can do is I can just do it like that. SCP sample3.txt file to the temp folder. I need to enter my passphrase again, dum-dum123. And you can see that now I just copied the sample3.txt file onto my server. By the way, let me just connect to my server so you can actually see that in action. I'm just going to SSH onto it. And now it gets boring already with the passphrase. So I'm just going to go into my temp directory. And here I can see now I have my sample3.txt file here. If you want to download files, by the way, you just need to swap the arguments. So you're just going to go SCP, then with the user, host, and the path of the file you want to download, or directory, even recursively with the -r parameter, and then the folder, the local folder that you want to download all the stuff to. It's quite handy for quick deployment. If you want to quickly, put some file somewhere on a server, just use the SCP command and be done with it. So as you already saw just now, every time I'm trying to connect to my server, I need to enter the passphrase for my private key file. Ideally, I'd just like to enter my password once per user session. So I logged into Windows, for example, I want my private key to be loaded automatically, and then with the password, and then not just have to worry about the passphrase anymore. For that, what you can do is you can use an SSH agent. Again, tiny differences, by the way. On Linux, macOS, you don't have to do anything. You'll have your SSH agent up and running. On Windows, what you need to do, just a quick debrief, you need to make sure that you go to your services panel, and then somewhere in here with the 20 million different services, you'll need to make sure that the OpenSSH authentication agent is running automatically. By default, it's not running, so you have to start it and you have to make sure it starts again. I'm actually going to paste some PowerShell commands in the references where you can automatically enable the OpenSSH agent. That's the only thing you need to do. On Mac, on Linux, you don't have to do anything for that to work. Now, what you'll now do is you'll go inside your SSH directory. You're going to call another command, which is called SSH add, and you're just going to put your private key file here. Now it's going to ask for passphrase, dum-dum123 just once. And when you now do SSH add -L, you can see, well, my so-called identity, this public key is added to my current SSH agent instance, which now means, by the way, let me just have a look. I'm just going to go up a bit. I can now connect to my server without having to enter the passphrase again, because my SSH command is talking to the SSH agent where the key file is in memory. And then you don't have to, load it again, put in your passphrase and whatever. You just have to do it once per user session. In fact, on Windows and on Linux, if you're using GNOME, for example, what happens is that your passphrase is now being stored securely also for your private key file and combined with your login password. And the private key file is being loaded automatically whenever you boot up your PC. So in fact, what happens is once you're logged into Windows or GNOME, for example, then you will have your private key file already inside your SSH agent without you having to do anything. On Mac OS, it's not completely automatic. I'm going to put a nice Stack Overflow discussion here where you see the couple of commands you need to enter to get this working as well. That brings us to another topic, which is SSH Client Config files. Now I'm inside my home directory .ssh subfolder. And in here, you can see that for now, I only have my private public key pair here and also my fingerprint that I got earlier, or my fingerprints rather. What you want to do is you want to create a new file, and I'm on Windows here, so I'm just going to create that, which is called config, nothing else, not config.txt, nothing, just config. And I'm going to open up with good old Notepad here, right? And where we have our config file, which is being read in by the SSH and SCP commands transparently without you having to do anything. Now, what are the contents of this file? Let's start with a basic use case. The basic use case could be nicknames. Imagine you want to have a host which is called dev, for example, your dev machine. Or let's say you're working on Facebook, so you're just going to host dev Facebook. Then you say, well, this is actually IP address, or the real host name is 18.195, or just some really long complex alphabetical name. And the user you want to use to connect to that host name is EC2 user, right? That's it. Let me make that a tiny bit bigger so you can see it. Now I'm just going to write SSH dev Facebook. And you can see automatically what happened. The SSH command had a look at it, matched, well, you mean host dev Facebook, right? The real host name is 18.195 something, and the user I should be using is EC2 user, right? That worked perfectly. You could also do stuff like, for example, saying, I want to put an identity file here because at the moment, SSH is still working with my SSH agent and supplying the private key file there. You could also say that, well, my host dev Facebook, for example, has a specific key file, which is in my home folder, downloads like we had earlier, Marco code spam, something like that, right? Go like this and have multiple hosts using different identity files, for example. Now, the thing is, this actually is not just, a quick nicknaming capability, because in fact, the host here, whatever is behind host, is more or less a pattern. So what you could do is you could say that host dev placeholder, for example, that everything that you put into the command line that starts with dev, right, always tries to connect with the user, EC2 user. And then if you had another dev, Facebook, and then you're in demand, you're also working for Google, for example, with a slightly different IP address. So 192, your home address, right, like so. Then every time you connect to dev Facebook or you to dev Google, also this pattern up here applies, dev placeholder, and it's using the user EC2 user. Let's try that out. SSF dev Facebook should still work. Right, that works as expected. And you can even have multiple patterns, not just one name here, dev Facebook, but also that is dev Facebook, and also for whatever reason, staging Facebook is also the very same thing. So play around with that. And we're going to have a look at more advanced config options in a bit. But nicknaming, for example, or listing all the servers you can access is one of the good basic use cases to use your config files for. Now let's check out other tools like GitHub, for example, that also allow you to work with SSH keys. How so? Well, if you have a private repository, for example, on GitHub, you could clone it with a username password combination, or what you do instead is you upload an SSH key. You can see I already have a couple of SSH keys associated here with my account. I'm just going to put my public key that we just generated, a couple minutes earlier in here, and I'll just call it Marco codes, for example. I'm just going to add that here and confirm that with my password. Now I have a private repo here, my private repo in my user. I'm just going to take the SSH URL here, not HTTPS. User password protected SSH key. Yeah, that's what we have already. So I'm just going to copy that here, open up my command prompt. I want to do a git clone. I'm going to paste in my repo here. Yes, it's the first time I'm connecting to github.com, so we're going to do the whole fingerprint dance. Yes, I'm going to trust you. The key was added, and as you can see now, my repository was just downloaded without me having to enter username or password or whatever. That just worked. Why? Because Git uses the OpenSSH client that's available on your machine. Hold on a second, that is actually only true by default for macOS and Linux. On Windows, if you want to make this work, what you have to do is you have to enter one command into your command line before, which I'm also putting into the references document down below. It's git config --global core.ssh command. You need to set it to C, Windows System, OpenSSH, ssh.exe. Why? Because on Windows historically there have been 20 million different ways of getting SSH to run. Git comes with its own SSH command. You could be running in Cygwin, whatever. What you want to do with the least amount of pain possible is just use Windows OpenSSH command with this configuration option, and then you never have to worry about it again. Now, there's one last trick I want to show you when it comes to GitHub and SSH keys. The problem is when you have multiple GitHub accounts, for example, my personal account, Marco Bieler, my work-related account, Marco Bieler JetBrains, maybe another one. And all of these obviously have different keys. Now, the problem is when you do a git clone, how do you tell the git command which private key to use to download a specific repository, to clone a specific repository? And as you might or might not have guessed, it has to do with the config file. So what you need to do is, in that case, what you want to do is you want to have a host that is, for example, called githubpersonal.com, something like that. The host name is now github.com, right? And then you want to specify your identity file there. So in my case, that would be my ID, the one we just added, ID 25519, and it's in my home directory .ssh subdirectory. In fact, let's call that GitHub work because that's my work key. Then I'm going to have another entry, GitHub. Let me see if I can spell correctly, right? Then we're going to have another section, which is GitHub personal. And then what happens is identity file, we're just going to go with the one with the key we created at the very beginning. It was in downloads. I think it was called marcocodes.pem, something like that. Right, now let's see how we can make this work. As a matter of fact, what I'm going to do is I'm going to get that URL here again. So the SSH URL. I'm going to do a git clone. I'm going to paste that in here. And there's one change you need to make here. GitHub.com now doesn't have to read GitHub.com, but rather the host you gave in your config file. So GitHub-work.com, for example, and the clone just automatically works. And whenever you're now cloning something with your personal key, a personal repository, you just do a GitHub-personal whatever, and then just, pick the other user account where you have your public key uploaded. And that way you can have multiple keys working with GitHub. It's quite a nifty trick to use the aliases from your SSH config file to do just that. Which brings us to yet another topic. Imagine you want to connect to dev Facebook. And on that server, for whatever reason, because it's your build server, for example, you want to do a git clone and then the repository URL. As you can see now, we're trying to connect from that server, but obviously my server doesn't have my private key file, so I don't have the permissions to actually clone the repository. And in fact, I also do not want to put my private key file onto a random server, whatever. So what do? Well, it's rather easy. What you need to do is open Notepad or the editor of your choice again. Go to your SSH Client Config file, open it up again, and then add a new option to dev Facebook, which is called forward agent yes. What does that mean? Well, let's try and connect to dev Facebook again, right? And now we're going to call SSH add-l. And suddenly what you can see is that my SSH agent on that machine now has the same identity that I have locally. That's because transparently, the SSH agent on the server now asks my local PC, hey, what identities do you have that I can try and authenticate with against github.com? So now what I do is when I now try to clone my repository on the server, as you can see, suddenly it worked and the repository got cloned successfully without me having to physically copy the private key file onto the server. SSH for Agent Forwarding, super useful in those use cases. Just put one tiny flag into your SSH config file. When we talk about SSH Agent Forwarding, we should also talk quickly about SSH Tunneling. What's the use case? Imagine I have a database on Amazon RDS. Now here's my endpoint. The thing is, I cannot from my local PC, from the internet, from the outer world, I cannot connect to that database. I can only use my EC2 instance, which I have created earlier, which lives in the same virtual private cloud, whatever, and use that to connect to my database. So when I open up my MySQL shell, because it's a MySQL database, and do a connect MySQL to that host name, you'll see that I can enter a password, which is fine, but then the connection simply times out, there's nothing happening. Now what I could do is I could SSH into my EC2 machine, and from there use the MySQL client, right? And then always use that as sort of a jump host. But there's even a better way to do all of that transparently with the help of SSH. So we need a new command line window. And what I'm going to do is I'm going to paste in a scary looking command. Don't worry, I'm going to walk you through it. So what we're doing here is we're SSHing through a machine, EC2 user, the IP address, which is essentially their Facebook machine. We could have written that there also. A couple of parameters I'm going to explain in the references section below. And then here is a local port. So whatever I'm going to send to localhost 3307 or which I'm receiving, please relay it through our jump host, which is the Amazon EC2 machine instance, to the final destination, which is Marco Test Me 3306, which is our database server. So I'm just going to run that. I'm not going to get any output here, right? So that should be working as expected. When I'm now going to go back to my MySQL shell, what I'm going to try is I'm going to copy that command that we just tried. Instead of going to the final destination, I'm just going to go to localhost 3307 because that was the port we just specified in the other window. And as you can see, I actually just connected to the server. So it connected to admin localhost 3307. The MySQL connection is 269, server version 8.0. That is the one that we have running on RDS. Pretty cool, isn't it, that this works transparently? But in any case, you don't actually have to worry with that command line so often because most database connection tools, even IDEs like IntelliJ, DataGrip and whatever, they have tiny little checkboxes where you can just put, the SSH IP address, your key file, and then you don't have to worry with all these flags and command line flags, unless you want to, obviously. Final topic for today. Now, when we double check our SSH agent so far, we only have one identity added to it. That's our dum-dum123 private key from early on. The question is, the key file is now on my desktop PC. What if I wanted to have it on my laptop also, my work PC, to have to copy it there? How would I actually handle that? And one solution to the problem, which I find super helpful, is using password managers which have SSH support. Now, I'm personally using 1Password. I'm not advocating for that. You could use KeePass, whatever. All these password managers have different levels of SSH support. But there's one very cool thing about 1Password, which you'll find out about when you go to 1Password settings. It has the ability to bring its own SSH agent, which means you need to disable the one that's running on Windows, for example, or macOS Linux. I'm going to show you references, documentation, text down below, how to do that. But when you have that, you simply click use the SSH agent from 1Password. What you then can do is when you now execute SSH add the command, you can see that suddenly it's not about that one file I added earlier on, but instead I have two keys saved in my 1Password account, right? And they're automatically available through 1Password's SSH agent. And I only have to unlock 1Password once on every PC I'm using, my laptop or anywhere else where I have 1Password installed. All right, that's about it for today's session. That is almost everything I know about SSH. Hopefully the stuff helps you in your day-to-day work life. Please feel free to comment. If you like what you saw, subscribe. Otherwise, see you in the next video. Sayonara.